Hi friends, this is Arun. In this video, we'll have a look at Big O or the time complexity. We are not going to talk about the book, The Missing Piece. It's also a good book to read. Have a look at it. But here our focus are more towards algorithm. So in an algorithm, what they mean by Big O and why it is needed. All those things we'll look at it. Okay. So let's start with the story or example. Then let's move on with finding the time complexity of different codes so that you can start using applying on your own programs, and whenever that is asked in an interview, you can answer it in a better way. I try to keep this thing as simple as possible. Okay. What the hell is this? Okay, why I should worry about time complexity? For example, there is always, finding a solution in this world is not a big deal. There will be always a solution for every problem. Somebody might have solved it, or you could have solved it in a way. But problem can be solved in multiple ways. In that, one way would be the efficient way, and finding the efficient way is the key thing, or assessing that is the efficient way is the key thing. How to assess something is efficient is with the help of time complexity we do it. So typically, when you don't know anything, let's assume I am going from here to Delhi. I go to every other city in between here and Delhi, and finally, if I reach Delhi, then that's called brute force. Okay, if I use somebody's logic and then find the shortest path, and go, that is the best algorithm compared to what I did. Okay, why this is so important? Let's see. So I have two sorting algorithms like a bubble sort and merge sort, and that is used in your mobile phone. Let's assume, okay. In the mobile phone, when you check the contacts and you try to sort the data and then get it. So during that time, let's assume the bubble sort takes around 10 milliseconds, whereas the merge sort takes only 1 millisecond. Which one you will prefer? Obviously, the lesser one, 1 millisecond guy. Okay, so if the data is just around 300, if it is taking 10 millisecond, and if the data grows to 3000 contacts, if it takes around 3 seconds or 5 seconds, how irritating it would be. Okay, so for doing these kind of analysis without having the data, or without putting all the data and running the live simulation, can we look at the code and figure out whether it's useful or not? Okay, the answer is yes, and that's the way that's the part of um, big O notation or the time complexity analysis. Okay, so here I have element application which is having 30 elements, and the other one is like 10 or 1000x faster than the B, which is you will prefer obviously the first one. Let's go to the code and see that. So in your program, if you wrote one line of code, that is considered as order of one. That is one statement is considered as equal to order of one. If it is two lines, order of one plus one, like that it is. Okay, so that is called constant time. Most of the cases we ignore this constant line of code if it is a single line of code. So the our main focus when we are going into time complexity is towards the looping statements. That's where the actual trouble starts. Okay, not in the single statement. The single statement mostly passes just like that. Okay, so let's see another example. Here I am printing, I am doing the a plus 1 for 5 times in the for loop. So the order of this program is around 5, o of 5. If it is instead of 5, if it is n, then it will be order of n. Okay, so that is the time complexity of a loop. A single loop, if it is running for n times, its order is n. Simple. Okay, it doesn't matter whether you increment one by one, like I plus plus or I plus 2, it doesn't matter. Okay, the when we do the approximation, it goes to n. So if it is 1000 elements, like it will go for 1000 times, like that we are assuming. Okay, and let's assume you have one for loop over the another for loop. So how it would be? It's like n cross n. So inner for loop runs for n times, outer for loop runs for n times. So it is n cross n, which is n square. So this is considered as one of the, I mean, not the worst, but it is considered as a bad programming. If you are not doing it right, we always try to optimize these kind of loops as much as possible. Okay, so in this better version is like trying to cut short any one of the loop, either for outer for loop or inner for loop, as much as possible. Okay, so even if it is like if it is a 3 for loop, let's see. Okay, let's before that let's go into this logarithmic style. So here I have while loop. instead of running, what it does is it's cutting it by half every time. So if something is cutting it by half every time, so the input size reduces, or the number of iteration reduces drastically. For example, if I have 1,000, next time it will become 500, it became 250, it will become 125, it became 75, like that. Okay. Same as the multiplication. Those factors are pretty good. Like log n is one of the good runtimes which people prefer. And if you have three for loop, it's n cube. It's just a multiplication of things. So when you have three for loops, always remember that your code is something is wrong until unless you are using a three-dimensional array. Even then, it's not the better way to do it. So let's see. I have program, and in that program I have 10 triple for loops, 4 double for loops, and one single for loop, 4 single for loop, and then 5 single line of statement. The order of n of this entire code is who is the weakest link in that, n cube. So the order is n cube. So in a class, if somebody is doing the homework pretty slow, and we can consider the entire class will complete within that person's time. Okay. So here in the first example, like 7n plus 2, so we usually ignore the constant, and we take as n. The same way, order of n cube for the second. And third one, we consider ignore the constant and make it as order of n. Okay. So these are various time complexities ordered in times of growing fashion. So order of one is the best, the constant time. Then comes the logarithmic time, which is log of n. Then linear. Then comes n log n. Then the trouble slowly starts. N square is a little bad, and n cube is getting worst, and exponential is the worst of the lot. So always remember, if you have a n cube, there is something wrong with your code. I mean, most of the cases. Okay, just go back and fix your code. This is examples for the particular thing. For example, order of n is array index lookup, which is always constant time. If you know the index, that is the best. Followed up with the binary search, which is log n. Then comes the linear search or the sequential search. Okay, where you have to search through the entire array. Then comes a heap sort and bubble sort of log n and n square. Then brute force is the n factorial thing for the traveling salesperson problem. All these are the worst case scenarios which people go for it. This chart simply shows what is the impact of input. For example, if you see the n is 1024, for log n it's only 10 searches, but whereas 2 power n it sees like 10 to power of 308 times speed. Let's assume if it is 10 seconds, so it is I mean 1 is equal to 1 second, let's assume. So it is like 10 to power 308 seconds time it is. And this chart I took it from the net. This is one of the good charts which you can paste it in your shelf, and this will be very useful while designing or writing a code or even appearing for the interview. Okay, thank you friends, bye bye.